Hello folks, welcome back. So in this session, let's see what is a stateless and a stateful server is. And let's also see what are the three different ways to run the MCP server. And 6 things to remember. Right, so once this is done, we'll also get started with the demo. First, the stateless and stateful server. Does your server remember anything between calls? That's the question. Right? If it is in stateless, every tool call is independent. Call add numbers now. Right? So call it tomorrow. And server doesn't know or care. Right? So every tool call is independent. You can call and tool like add numbers now or call it tomorrow, day after tomorrow, whatever it is. The server doesn't know or care. Right? So why is this good? It's good for scaling. When you have something as stateless, it's good for scaling. You run 10 replicas behind a load balancer. Any replica answers any request. Right? So any replica answers any request. And debugging. Same input, same output always. Same input, same output always. So let's take an example of an ATM card. Right? So you insert the card, get the cash. The ATM doesn't remember your last visit. Right? So, and that's exactly why any ATM in the city works for you. And let's speak about stateful. What an stateful is. The servers remembers. If a server remembers the sessions, the subscriptions, the long running jobs, that's what I call it as a stateful. In streamable HTTP, this is what the MCP session ID headers enables. Right? So we spoke about this ID again and again. Right? So in the streamable HTTP, this is what this MCP session ID header enables. Right? Now tell me when this file changes. Right? So if I'm going to ask, we are going to have this for resource subscription. Tell me when this file changes. 1 RN per user workspace. Right? So let's take an analogy so you may better understand it. So a personal assistant who remembers what you have done yesterday. What are the meetings that you have committed for today and tomorrow? Right? So as an industry default, making your tool stateless becomes very helpful. If your application needs memory, keep it outside the tool. Do not integrate it with the tool. Right? So you're going to keep that memory outside the tool in a database, in a vector store, something like that. Right? So this is exactly what we are going to do and what we have did in the previous live sessions as well. So our multi-server client had a memory component, the conversation memory that's lived in the client. Right? So the calculator, weather, currency servers, that stayed completely stateless. Right? So if you have to say this in one line, smarter clients have simple servers. Right? So we don't complicate. It's smart client, simple servers. Right? Now, let's say if one of the students is going to ask a question. Our weather tool calls. Right? So we had the weather tool. Does it call an external API? Right? So if it calls an external API, is that state? Is that what you call it? We are going to call it as a state. Right? So we are going to say what is the weather in Mumbai? What is the weather in New York? Right? So our weather tool is going to call an external API. Right? So the open weather API is something. Is that a state? No. Stateless means the server keeps no memory between calls. The server keeps no memory between calls. Fetching external data each time is perfectly stateless. Right? Now, another question that you may ask here is, so where did the memory in our live session live? It lives in the client application. The conversation history stayed here. So all 4 servers remain stateless. Right? So simple client, simple servers. All right. Now, okay. The practical question. So how do you actually run your server? There are 3 different ways. Now this table is your cheat sheet. You can even take a screenshot of it. Option 1 is mcp.run. So the built-in one-liner from fast MCP. Create the server, decorate your tools, call mcp.run. That's it. This is perfect for learning and quick demos. Right, so minimal port control, hard to run several servers side by side, and limited logging. And remember from the previous slide, the modern transport value is streamable HTTP, not the SSE. Right, so it has been changed. And option 2 is uvicorn.run. What we used in the what we are going to use in the live session and the previous live session and all the demos. MCP hands you an ASGI application, and you run it with Uvicorn. Exactly like in Fast API application. So here what happens? You have the full port control. 8001 for a calculator application, 8002 for weather, 8003 for web search, 8004 for currency. So multiple servers, multiple clients, middleware, proper logging, everything is present. So this is a production choice. Now, then why option 3? Let's also explore this. Stdio subprocess. There's no port at all. Now, the client launches your server as a child process and talks over pipes. Right? So the client launches your server as a child process and talks over pipes. This is what Cloud Desktop does with local servers. Right? So this is what the Cloud Desktop does it with the local servers. This is ideal for ID integrations and personal tools. Right? So one client, one server, and it's local only. By design, right? So it has only one client, one server, and it also runs local only by design. Right? So if I have to say, it has a golden rule. If one developer's laptop you want to build a solution, Stdio. Right, so Stdio will work here. Now, learning or demo. If you're just learning or demoing it, mcp.run. mcp.run is the choice. For real users and production grade, Uvicorn with streamable HTTP is the end solution. Right, so I think by this slide, it's very well summarized. Now, if I have to ask a question, right? So thinking from a student perspective, can I deploy an MCP server in Docker on the cloud? Yes, with Uvicorn plus streamable HTTP, it behaves like any ASGI web service. You're going to containerize it, right? So containerize it, put it behind a load balancer, done. Right, so which model should we use it for the course project? You can use the Uvicorn, same as the live session, one port per server. Right, so 8001 for calculator, 8002 for weather API, 8003 for RAG application. Right, so for separate ports, separate servers. Let's lock in the 6 takeaways from these sessions. 3 rules. Host is the application. Client speaks the protocol. Host is the application, client speaks the protocol. One client per server. And the server owns and executes the tools. Server owns and executes the tool. The LLM only chooses, it never executes. Number 2, language. JSON RPC 2.0. Right, so next is JSON RPC 2.0. 3 message types. What are the 3 message types? You can pass and you can also recitate, right? So the first is request. Request is ID. Number 2, response. Right, so the same ID, result or an error. Right, so request is an ID. Response, the same ID is going to give either a result or an error. The third one is notification. What is the importance of notification? It's just fire and forget. Right? So notification, there's no ID associated with it. That is what 3 message types in the JSON RPC 2.0. Please remember it. And number 3, handshake first. Initialize and capabilities are agreed and initialize the notification, then tools. Right? So nothing before it. And number 4, the capabilities define the session. Servers offer tools, resources, prompts, logging. Clients offer routes, sampling, and elicitation. Right? So this is the 4th important point. And number 5, 2 standard transports. Stdio. Right? So where std out is secret. Right? So we mentioned that, right? So 2 standard transports, stdio, where std out is secret, and the second one is streamable HTTP. Right? So what is a streamable HTTP? With its single MCP endpoint. Right? So with its single MCP endpoint. Right? So you should remember HTTP plus SSE is deprecated. In the previous sessions we had this. HTTP plus SSE is deprecated. The modern word is streamable HTTP. That is what we are currently having. And stateless by default. Keep tools stateless. Memory in the client or a database. And demos, you use mcp.run. And local is stdio. Production is Uvicorn. So these are the important points that you need to remember. If you can explain the 6 points in your own words, you can handle any MCP architecture question. That's a guarantee in any interviews or in any design reviews. Right? Now, if your question is, what should I revise for interviews? These 6 points. Right? So these 6 points are very important. Plus, describe the handshake. Right? So in the previous slides, we had the handshake. Right? So, and name the 2 transports with the SSE. With the SSE correction that we mentioned. Right? This combination covers 90 to 95% of all the MCP questions. So now you don't just know what MCP is. You know exactly how it works internally. The roles, the messages, the handshake, the transports, and how to run it. Right? So in the forthcoming videos, we'll put all of this into practice. We'll build an MCP server from scratch using fast MCP, a calculator, and a weather tool, document strings that the LLM actually reads to make decisions. And a tool most tutorials skip, the MCP inspector. Let's also deep dive into what is this MCP inspector to test your server before connecting any AI to it. Right? So, and thank you, and I'll see you in the next session.